Geometry Chapter 1 Lesson 9, we want to take a look at area. We talked about it a little bit in our first video, but I want to cover it more specifically in this video. Now, to find area, we need to have the same unit for both dimensions, meaning if you're given one side given in feet and another side given in inches, because you're going to be multiplying those together, they have to be the same units. So you would have to convert one from inches to feet or from feet to inches one way or the other. So the units must be the same. That's going to give us the number of squares that could be fit inside the figure, and our units are always going to be squared because we're multiplying these units together. So, and the units are the same, then we're going to have square units. Alright? Now, determine the area of a square. No, determine the area of a circle. So the area of a circle is equal to pi r squared. So we're going to use this, and again it says leave our answer in terms of pi, so we're not going to do anything with this pi in terms of putting it, multiplying it out. So it's pi times the radius. Now I have to have the radius, and in this formula I'm only given the diameter. The diameter is 2 radii, so if I multiply or divide the radius by 2, that's going to give me my radius. Now, many of you will probably want to turn that into 7.5, but I'm going to leave it as 15/2 because I'll show you it's easier to square a fraction than it is to square a decimal, at least without the use of a calculator. So here we have pi, and to multiply fractions we multiply numerator times numerator and denominator times denominator. So actually when I square a number, it means I multiply it by itself. So to square a fraction, I simply square the numerator, 15 squared, which is going to be 225, and then square the denominator over 4. So my answer is, my area is 225 over 4 pi, and then centimeters squared, the units will always be squared. So this would be my answer, and I don't have to do anything more with that. I could just leave it like that. The only thing I would do any further would be to simplify the fraction if I could. But this doesn't simplify anymore, so this would be how I can leave it. Now I'm fine with that. I'm fine with doing it like this. If you change it to a decimal, then go ahead and check your answer. It's probably a decimal. It'll be 56.25 centimeters squared, but changing it to a decimal is really not necessary. And later on when you go to college or something like that, and they're going to do a college entrance exam, those entrance exams don't allow you to use a calculator, so being able to do it without would be a good thing to practice now. So let's do one more. We have area here of a circle, and again area is pi r squared, so we're going to put in the 5 and then it's squared, and then we're going to multiply it out. So 5 squared is 25. We leave pi because it's in terms of pi, and then our units are always squared with area. So here we have the area of a circle in terms of pi. Again, don't multiply out pi unless they ask you to round off the answer. So unless that would be the only time that you would use 3.14 or anything else. Okay, quickly I want to look at irregular shapes, and irregular shape figures are just well, it goes through these postulates, but I really don't want to even talk about it too much. You can read that in your book. So if we want to determine the area of this figure at the right, well, it's not in a square, it's not a rectangle, and it's not a circle, and those are the only things that we've talked about. So in a shape like this, what you can do is, or what you need to do, is to divide this thing into squares and circles, or half circles, or something like that. And there's multiple ways you could do this. So if I did this and put these lines in here like this, you'll notice I actually have 3 rectangles and a square. Here's a square or rectangle, here's a square or rectangle, or here's a square or rectangle. So to figure out the area of this, I just need to figure out the area of each of these rectangles and then add them together. So the tick marks tell me that all of these are 2 in length, so that's a 2, that's a 2, that's a 2, that's a 2, that's a 2. So I could figure out the area of this one, length times width, 2 times 2. So the area of this first one would be 4 square units, length times width. Then if I look at this rectangle right here, okay, this is 2 units this way, and then I need to know the length. Well, what's the length? Well, these tick marks tell me that this whole thing is 2, so if I take 2 away from that, that means this is going to be 4. So the 2 this way and the 4 this way is going to give me the area of that. 2 times 4 is 8. And then I can do this last rectangle, again, using the fact that I know this is 2 and this is 6, so that's 12. So then I simply add those together. 12 and 8 is 20, plus 4 is 24. So the area of this figure is going to be 24 centimeters squared. Now I did that without writing out any of my work, but don't you do that, because we want you again to show all your work. So I just did that to show you. And again, you add the 3 together, you figure out each one, and you get the area. Now you could have maybe decided to go this way with your rectangles, and that would have been fine too. You would have found this one, this one, this one, add them together. So sometimes you may do it differently than someone else, but as long as you calculate it and figure it out into the same thing, then you might be okay. Someone else might have done this. You see how they did this? Where you could have taken this square here, figured out that, so you could have done this, this, and this, and added them together. So there's multiple ways to do it depending upon how you see it. But the idea here is, if it's a shape that's not a circle, square, or rectangle, but a combination of those shapes, you simply need to divide it into the 2 shapes or 3 shapes, and then do each one separately and add those together.